Sairam. Good morning, children. Last class we have studied zeros of a polynomial and remainder theorem. So let us revise it once again. Zeros of a polynomial. Let p of x be a polynomial and a is any number. A is any number. If x is replaced by a, we will get the value of the polynomial at x equal to a. Then if this a, p of a equal to 0, we can call, if p of a equal to 0, we can call a is a 0 of the polynomial. A is the 0 of the polynomial. That is, if p of x be a polynomial and a is any number, if x is replaced by a, we will get the value of p of x at x equal to a. And if this p of a equal to 0, we can call a is the 0 of the polynomial. For example, let p of x equal to x plus 3. If x is replaced by a number minus 3, we will get p of minus 3 equal to minus 3 plus 3, which is equal to 0. That means p of negative 3 equal to 0. So we can call negative 3 is a 0 of the polynomial x plus 3. This already we have discussed in the last class. Then in the last class we also have discussed about remainder theorem. What was this remainder theorem? This remainder theorem states, let p of x be a polynomial of degree greater than or equal to 1. If n is the degree of that polynomial, n should be greater than or equal to 1. And let a be any real number. Any real number means any number that you have studied. Any real number. Then if this p of x is divided by a linear polynomial x minus a, the remainder will be p of a. The remainder will be p of a. So without long division, we can find the remainder if p of x is divided by a linear polynomial using this remainder theorem. For example, let p of x equal to x raised to 4 minus x cube plus 2x minus 1. Suppose this p of x is divided by a linear polynomial. Suppose it is x plus 4. X plus 4. We have to get the remainder by using this remainder theorem. For that, we have to give x plus 4 equal to 0. So, x equal to negative 4. X equal to negative 4 we have to give here. So, we will get p of negative 4. P of negative 4 will be the remainder. It is equal to negative 4 raised to 4 minus negative 4 raised to 3 plus 2 into negative 4 minus 1 will be the remainder of this p of x is divided by x plus 4. This both topics we already have discussed in the last class. Children, now we know what is remainder theorem. In remainder theorem, p of x is a polynomial and p of x is divided by a linear polynomial x minus a, where a is any number, then the remainder will be p of a. Remainder will be p of a. Using remainder theorem, remainder will be p of a. If this remainder is 0, if remainder is 0, this x minus a will be factor of p of x. That is, if remainder is 0, the divisor will be the factor of p of x. For example, whenever we are dividing 18 by 3, we will get the quotient as 6 and the remainder as 0. So we can call 3 is a factor of 18. In the same way, here remainder is 0. So this x minus a will be factor of p of x. And this is called factor theorem. P of a equal to 0. If p of a equal to 0, then x minus a will be a factor of p of x. This is called factor theorem. So what is this factor theorem? Let p of x be a polynomial of degree greater than or equal to 1, and let a is any real number. Then first condition, x minus a is a factor. X minus a is a factor of p of x when if p of a equal to 0. In vice versa, we can say p of a equal to 0 if x minus a is a factor of p of x. So this factor theorem says that let p of x be a polynomial of degree greater than or equal to 1 and let a be any number. Then by this factor theorem, x minus a is a factor of p of x if p of a equal to 0. Or we can say p of a equal to 0 if x minus a is a factor of p of x. By some examples we can clear it, children. Now we can solve this question using factor theorem. The question is this: check whether x minus 1 is a factor of the polynomial 4x cubed plus 3x squared minus 4x minus 3. For that, first of all we can find the remainder. So first let us p of x equal to 4x cubed plus 3x squared minus 4x minus 3. Here we have to check whether x minus 1 is a factor. So x minus 1 equal to 0, x equal to 1. So x we can give the value 1. That is p of 1 equal to 4 into 1 cube plus 3 into 1 square minus 4 into 1 minus 3. That is 4 plus 3 minus 4 minus 3. Plus 4 minus 4 cancel. Plus 3 and minus 3 also gets cancelled. Which is equal to 0. That is p of 1 equal to 0. So what we can conclude? We can conclude x minus 1 is a factor of the given polynomial since p of 1 equal to 0. That means here we got remainder as 0. So this x minus 1 will be factor of the polynomial p of x. Children, let us consider one more example. Here one question, another question. Check whether x plus 2 is a factor of x cube plus 3x square plus 3x plus 1. That means the given polynomial is x cube plus 3x square plus 3x plus 1. We have to check whether x plus 2 is factor of this p of x. For that, we have to find the remainder. For that, x plus 2 equal to 0 and x equal to negative 2. So we have to find p of negative 2, which is equal to negative 2 cube plus 3 into negative 2 whole square plus 3 into negative 2 plus 1, which is equal to negative 2 into negative 2 into negative 2, which is equal to negative 8 plus 3 into negative 2 into negative 2, which is positive 4 plus 3 into negative 2 which is equal to negative 8 plus 12 minus 6 plus 1. That is minus 8 plus 12, 4. 4 minus 6 minus 2. Minus 2 plus 1 minus 1. Now we got P of negative 2 equal to negative 1. So what we can conclude? X plus 2 is not a factor of P of x. Since P of negative 2 not equal to 0. If P of negative 2 is 0, we can conclude x plus 2 is a factor of P of x. But here we got P of negative 2 as negative 1. So x plus 2 is not a factor of P of x using factor theorem. Children, next we can consider one another type of question to use factor theorem. The question is this: find the value of k if x minus 1 is a factor of P of x equal to kx square minus root 2x plus 1. Here it is given that x minus 1 is a factor. Children, you know in factor theorem we studied if x minus a is a factor, then P of a equal to 0. The same theorem we can apply here. If x minus a is a factor, P of a equal to 0. Here it is given that x minus 1 is a factor. X minus 1 is a factor means x equal to 1. If x minus 1 is a factor, then P of 1 will be equal to 0. Because if x minus a is a factor, then P of a equal to 0. So here P of x equal to kx square minus root 2x plus 1. So it is given x minus 1 is a factor. Since x minus 1 is a factor, P of 1 will be equal to 0. What will be this P of 1? We have to give 1 in the place of x. So P of 1, k into 1 square minus root 2 into 1 plus 1 equal to 0. That is k into 1 square is equal to k minus root 2 plus 1 equal to 0. That is k equal to, when minus root 2 transposing, we will get plus root 2. Then when plus 1 transposing, we will get minus 1. So the value of k is root 2 minus 1. I will explain it once again. The question is, find the value of k if x minus 1 is a factor of P of x. If x minus 1 is a factor, using factor theorem, P of 1 will be equal to 0. So we can find P of 1. P of 1 will be k into 1 square minus root 2 into 1 plus 1. That will be equal to 0. That is given. It is given that x minus 1 is a factor. So P of a will be 0. Here it will be P of 1. P of 1 will be 0. So P of 1 is 0. Then replace each x by 1. We will get k into 1 square minus root 2 into 1 plus 1 equal to 0. That is k minus root 2 plus 1 equal to 0. By transposing, we will get k equal to root 2 minus 1. Children, our next topic is factorization of quadratic polynomials. You know what are quadratic polynomials? What are quadratic polynomials? Polynomials having degree 2 are called quadratic polynomials. Here one question is this: x square minus 5x plus 6 we have to factorize this. You can factorize this using factor theorem. For that, first of all, let us take p of x equal to x square minus 5x plus 6. Here, the constant term is 6. Which are the factors of 6? The factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So we can check each number to get the factor. For that, first of all, we can take p of 1. P of 1 equal to 1 square minus 5 into 1 plus 6, which is equal to 1 minus 5 plus 6, that is negative 4 plus 6, which is equal to 2. Since p of 1 equal to 2, x minus 1 is not a factor. Since p of 1 not equal to 0. If this p of 1 we got as 0, we can say x minus 1 is a factor. Now we got p of 1 as 2. This is not equal to 0. So x minus 1. Because here we found p of 1. So x minus 1 is not a factor. Not a factor. Then next, so plus 1 we check. Then we can check minus 1. P of minus 1. P of minus 1 equal to minus 1 square. In this we can give x as minus 1. Minus 1 whole square minus 5 into minus 1 plus 6, which is equal to 1 plus 5 plus 6. That's equal to 12. That also not equal to 0. So x p of minus 1. Here we found p of minus 1, which is not equal to 0. So x plus 1 is not a factor. Is not a factor. Then our next number is plus 2. P of 2. We have to find p of 2. P of 2 equal to 2 square minus 5 into 2 plus 6, which is equal to 4 minus 10 plus 6, which is equal to 0. That is p of 2 equal to 0. So we can conclude x minus 2 is a factor. X minus 2 is a factor since p of 2 equal to 0. Then next, here this is a quadratic polynomial. A quadratic polynomial has at most 2 factors. A quadratic polynomial has at most 2 factors. So that we can find. Then next p of plus 2 we checked. Then we have to check p of minus 2. P of minus 2 equal to minus 2 square minus 5 into minus 2 plus 6, which is equal to 4 plus 10 plus 6, that is 20, not equal to 0. So x plus 2 is not a factor. X plus 2 is not a factor. The next number, p of plus 3. P of plus 3. That's equal to 3 square minus 5 into 3 plus 6. This is equal to 9 minus 15 plus 6. It is equal to 0. So x minus 3 is a factor. Because p of 3 equal to 0. Now we got 2 factors, x minus 2 and x minus 3. Then no need to check other numbers. Since this is a quadratic polynomial, it will get only 2 factors. That 2 factors we already got. Here we can stop the factorization. So the factors of x square minus 5x plus 6 are x minus 2 and x minus 3. Children, for this we consumed more time. So there is another method for doing this. Here we applied factor theorem. By another way, you already studied how to factorize this. The method was that find two numbers such that their sum as negative 5 and product as plus 6. We have to find two numbers such that their sum is the middle term and product is the last term. So sum negative 5 and product positive 6. So such the two numbers you have to find. For that we have to find the factors of 6. The factors of 6 are 1, 6, 2, 3. Plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. Children, but here we have to get the product as plus 6. Plus 6. Which two numbers multiply we will get plus 6? Either minus 1 minus 6 plus 1 plus 6 or minus 2 minus 3 plus 2 plus 3. Minus 1 into minus 6 positive 6 plus 1 into plus 6 positive 6 minus 2 into minus 3 positive 6 positive 2 into positive 3 also positive 6. And here we have to get sum as negative 5. Sum negative 5. In which pair we will get sum negative 5? Minus 1 minus 6 we will get minus 7. Plus 1 plus 6 we will get plus 7. Minus 2 minus 3 we will get minus 5. When we are finding the sum we will get minus 5. Plus 2 plus 3 plus 5. So this pair we have to take. Minus 2 and minus 3. So the factors of x square minus 5x plus 6 are x minus 2 and x minus 3. This is the factorization of x square minus 5x plus 6. This we solved in 8th standard using the identity x plus a into x plus b. X plus a into x plus b. That is x square plus a plus b into x plus ab. Actually we applied this here. That is x square minus 5x plus 6. We can be written as x square plus minus 2 plus minus 3 into x plus minus 2 into minus 3. That is x minus 2 into x minus 3. This method we already studied. So I think this method is more easier than the first method we discussed. We got the same factors there also, x minus 2 and x minus 3. Then another example for factorization. The question is this: 6x square plus 17x plus 5. We have to factorize this polynomial. There is a difference between the last question and this question. In the last question, the coefficient of this x square was 1. So we have to find only two numbers such that sum as the middle term and product as the last term. But here the coefficient of x square is 6. In this case we have to split the middle term. We have to split the middle term in such a way that sum as the middle term. Sum as the middle term. Split. Sum as the middle term and product as sum as the middle term and product as product of extremes. Product of extremes. Product of extremes. Sum middle term. So sum should be 17x. With the sign we can write sum as plus 17x and product. Product should be the product of extremes. Extremes means here 6x square and 5. 6x square into 5. That is 30x square. So you have to split the middle term 17x. In which way you have to split? You have to split the sum as 17x, the product as 30x square. So for that we have to find the product of 30. Product, not factors of 30. Which are the factors of 30? 130. Factors of 30. 130, 2, 15, 3, 10, 4 is not a factor, 5, 6, like that. And in this pair, we have to get sum as 17. In all these pairs, product is 30. But in this, we have to find the pair which has the sum 17. So clearly 2 and 15. 2 and 15 has the sum 17 and product 30. So we have to split this 17x as 2x and 15x. 2x and 15x. Their sum is 17x and product is 30x square. So 6x square plus 2x plus 15x plus 5. Only we split the middle term here. 17x as 2x plus 15x. And from the first two we can take common factor. Which is the common factor? The common factor is 2x. 2x into 3x plus 1. And from the next two also we can take common factor. Which is the common factor here? 5. So from that we can take 5. If no common factor you are getting, you have to take 1 outside. 5 into 3x plus 1. And you look here, in the first term 3x plus 1, in the next term also 3x plus 1. So we can take 3x plus 1, again common factor outside, into, here remains 2x and here remains plus 5. So the factorization is over. The factors of 6x square plus 17x plus 5 are 3x plus 1 and 2x plus 5. Children, we can consider one more example for factorization of quadratic polynomials. The example is this: 6x square plus 5x minus 6. Here also the coefficient of x square is not 1. So we have to split the middle term. In which way we have to split it? You have to split the middle term in such a way that sum as the middle term. That means sum plus 5x and product as the product of extremes. That is, product should be here 6x square into negative 6. That means minus 36x square. Product should be 6x square into minus 6, which is negative 36x square. Then we can find the factors of 36. 1, 36, 2, 18, 3, 12, 4, 9, 6, 6. These are the factors of 36. And from this, we have to find a pair which has the sum plus 5. So we can use any sign here, plus or minus, but you have to get the sign sum as plus 5x and product as negative 36. So here we will not get 5, here we will not get 5, here also we will not get 5 as the sum. But here 9 and 4 there is a possibility to get sum 5. If we are getting plus 9 and minus 4, we will get sum as plus 5. Minus 4 and plus 9, we will get sum as plus 5 and product negative 36. So we have to take this way. Negative 4x and plus 9x. So we can do 6x square minus 4x plus 9x minus 6. So we split here middle term 5x as minus 4x plus 9x. Then from the first two we can take the common factor. Which is the common factor? 2x. 2x into 3x minus 2. And from the next two we can take 3 as the common factor. The remaining 3x minus 2. So 3x minus 2, 3x minus 2 again common. That also we can take outside. So 3x minus 2 into 2x plus 3. Now our factorization over 3x minus 2 into 2x plus 3. Children, today we have learned about factor theorem and factorization of polynomials. I hope all of you got it well. After each class, we are sending the notes to you. You have to copy it in your maths notebook neatly. And whenever I am calling you, you have to send the notes to me personally. And you do one thing, every day you have to practice maths. Because there is a chance for forgetting. Only one class we are getting per week. So don't worry. Whenever you are practicing at that time, if you feel any doubt, you can call me directly. We can see you on next session. Thank you.